back to your favorite intermediate algebra class. We're going to talk about slope and rate of change today. Our objective is to find slopes of lines and to work with them and understand fully that concept. And so let's start out talking about slope. The definition. Well, it's the ratio of vertical change, the rise, to horizontal change, the run, for a non-vertical slope. So if you have, say you got this line here with x1, here's your point x1 and y1, right? And we got over here x2 and the point x2, y2, okay? The vertical change, m represents our slope. So the ratio of the vertical change, y2 minus 1, so the difference here, like let's say this was 5, and maybe this was 3, right? 5 minus 3 is our difference there. So we have 5 minus 3, or in other words, y2 minus y1, that ratio of y2 minus y1 over x2 minus x1. Like maybe this is 1 and this is 4, so 4 minus 1, which is 3. So that ratio of rise to run determines the steepness that we have of that line. Okay, how steep is that line end up being? Vertical change to horizontal change here. Okay, slope of a line, steepness. So let's find the slope of a line passing through -2, 0, and 1, 2. So we have -2, 0, and then we got 1, comma 2. Okay, -2, 0. How steep is this line to 1, comma 2? So the first thing we do is we say, well, it's the ratio of the vertical change. Oops, that's y2 minus. Sorry, that jumped on me there. y2 minus y1 over x2 minus x1. We go ahead and name this x1, y1, x2, y2, and we plug them in. So our y2 is 2 minus our y1, which is 0, over our x2, which is 1, minus our x1, which is -2. Then we just solve that thing. So 2 minus 0 is 2. 1 plus a 2 is 3. So it looks like our slope here ends up being 2/3. That's our ratio of the vertical change to the horizontal change, the steepness of that line there. Classification of lines by slope. Well, if you have a slope that's positive, okay, like that last one we had a slope that was 2/3, right? That's what it's going to look like. So you go up and to the right there, okay? Now if your slope is negative, okay, let's say we do the formula, we get a slope of -4, it's going to go down and to the right, okay? If our slope is 0, it's going to look horizontal. And if we have an undefined slope, so when we solve the thing, you do this y2 minus y1 over x2 minus x1, if you get a 0 on the bottom, your slope is undefined there, okay? When you go to plug those points in, you got a vertical line if you have points to plug into the equation there. It becomes undefined. Call that an undefined slope. Okay, so without graphing this thing, let's plug this into the slope equation, tell whether the line is given points, with the given points, rises, falls, is horizontal, or is vertical. Okay, so we go, well, x1, y1, x2, y2. Let's see what this slope is. y2 minus y1 over x2 minus x1. Make sure you memorize that. 4 minus the -4. Plug those in. Well, 3 minus 3 is 0. 4 minus the -4. 4 plus 4 is 8. 0 divided by any old number is 0. So our slope is 0. Okay, so we have a horizontal. This line will be horizontal. Right, and if you think about that, you're like -4, 3, and then 4, 3. 4, 3, like, oh yeah, that thing's going to be perfectly horizontal, right? If you were to graph it. I know it tells you not to without graphing, but if you were. All right, how about this one? Go ahead, plug it in again. 0 is your y2 minus your y1, which is 2. x2 is 3 minus your x1, -2. 0 minus 2, negative 2. 3 plus 2 there is 5. Slope is negative 2/5. Negative 2/5. So since our slope is a negative number, we know it's going to fall, right? It falls because our slope is negative. If you go back to this picture, negative slope is saying it falls. Okay? All right, let's go on here. Line 1, tell which line is steeper. And let's talk about steepness for a minute. Let's say we have two lines, and here's one, and let's say this slope is 1, and we have this other one, and its slope is 3, okay? If they're both positive slopes, you can compare them, and you can say, well, the one, let's call this slope 1, m subscript 1, slope 2, m subscript 2. If the line 2, so this line is steeper because m2 is greater than m1, okay? So there you would say that line 2 is steeper, okay? So you got to find what your slopes are to compare them. If, on the other hand, let's say they're both negative, okay, let's say this slope is negative 2, and then the other slope is negative 2/5. This is line 1, this is line 2. Okay, you say, well, line 1, as you can see, is a little steeper. You see how it falls quicker there? Line 1 in this case is steeper, and that's because the slope on that is actually less than the slope on the other one, slope 2. This is slope 1, slope of line 2 there. Okay, so in other words, it's more negative, if you will. Whereas when you're comparing them with positive slopes, you wanted the larger positive number. Okay, so keep that in mind when you're finding these and comparing steepness. You're comparing steepness, okay? All right, so part A. Line 1 is through negative 1, 0, and 0, 5. So let's do slope of line 1. y2 minus y1 over x2 minus x1. So we get 5 over positive 1. So slope 1 is a 5. And then we'll go and we'll compare that to this line 2, which goes through 2, 4, and 3, 7. x1, y1, x2, y2. Of course, I'm plugging it into this, right? 7 minus 4 over 3 minus 2. So we've got 3 over 1. So slope of line 2 is 3. Well, they're both positive. Which one's going to be steeper? That one's going to be steeper because it's more positive, right? You say line 1 steeper since slope of 1 is greater than the slope of 2. Okay? Let's do part B here. Oops, can't see that. 1, negative 5 to 4, negative 8. y2 minus y1 over x2 minus x1. So negative 8 plus 5, negative 3 over 3. Here's our slope of that line 1. Our other one looks like it's 0, 1, and 2, negative 5. y2 minus y1 over x2 minus x1. So it looks like we got negative 6 over 2 or negative 3. Okay? You're comparing these. You say, well, they're both negative, so I can compare the steepness. Which one is steeper here? The more negative number, right? The more negative number. So it's actually line 2 is steeper here in this case, since our slope of that 2 is less than the slope of that line 1. Okay, but line 2 is steeper. All right, let's talk a little bit about parallel and perpendicular lines. Well, if you recall from your beginning algebra course, parallel lines, if they do not intersect, they are parallel. Well, if they don't intersect, then they must have the same slope. If they don't have the same slope, they're going to intersect at some point. Okay, so to be parallel, slope 1 must be equal to slope of line 2. Now, if they are perpendicular, that means they must not only intersect, but they must create a right angle, okay? And their product must be equal to -1, or they are opposite reciprocals, okay? So for example, let's say for line 1, this one right here, okay, let's say its slope of line 1, let's say it was -2/5, okay? Then line 2, if these are truly perpendicular, then line two's slope must be the opposite reciprocal. So you flip it, and you change the sign. It was negative, now it's positive, okay? Those two, line 1 is perpendicular to line 2, okay? Up above here, we had line 1 being parallel to line 2. Those are the symbols for perpendicular and parallel, respectively, right? That's parallel, that's perpendicular, if you've forgotten that. Okay, let's do some problems now with that. Tell whether the lines are parallel, perpendicular, or neither. So part A, line 1 looks like we have 1, 1, 0, 4, find your slope, 4, y2 minus y1 over x2 minus x1. Looks like we got 3 over -1, -3. Now let's do a slope for this other one. -3 minus 3 over 0 minus a -2. So it looks like -6 over +2, -3. And you say, let's see, slope of the first line was -3. Slope of the second line, the exact same thing. So line 1 is exactly parallel to line 2. They have the same exact slope. And of course you could plot the points and you could see that, but that's your verification there that they are. Let's break verification. All right, part B here. Now you got this line, -1, -1, and 2, 3. Let's find this slope, 3 minus the -1, y2 minus y1 over x2 minus x1. Looks like we got 4 here, 2 plus 1, 3. Slope is 4/3. Now, if these are parallel, my next one, when I find this slope, if they're truly parallel, it will also be 4/3, right? Because they're parallel. If they're perpendicular, this slope over here would be -3/4, okay? So let's see what happens here. They're parallel, perpendicular, or possibly neither, right? So we find it. 2 minus the -3 over -3 minus the 4. We got 5 over -7, -5/7. You say, well, are they the same? Is that the same as that? You say, nope, they're not. Is 4/3, is it the opposite reciprocal? Is it -3/4 over here? Nope, it's not. So they're not perpendicular either. So you just say neither. Okay, make sure you bring any questions you guys got to class. See you soon.